Derivatives of sums and differences. So if you have two functions added together, f of x plus g of x, and you want to take the derivative of that, turns out you can take the derivative of f of x plus the derivative of g of x. Similarly, if you have two functions that are subtracted from one another, you again can take the derivative of each function individually and subtract their differences. So what that means is if you have a function of things that are added and subtracted, you can go term by term using the rules to take the derivative, and you will get your resulting derivative by adding or subtracting them in the same order that the original function was presented. So let's go ahead and try a couple of examples that use this property. Example 4. Use the formulas to find each of the following derivatives. So notice here that we have multiple terms in one function. So here for part A, the sum and difference rule says that I can go term by term and take the derivative of each part. So I start with my x to the 5th. The derivative of that is going to be 5x to the 4th. The power comes down and you subtract 1 from the power. Minus, now we have 2x squared. So the 2 comes down to multiply the 2 from our constant multiple rule, and we get 4x to the 1 plus, now the derivative of 6x, when you have a constant times x, the derivative is just that constant. And then the derivative of 1 is 0. So that means that we're going to have 5x to the 4th minus 4x plus 6. We don't usually write the plus 0, and we also don't usually write the 1 power, but I'm writing it here now so we can see how the rules have been enacted. So now for part B, we have the function 3x cubed minus x to the 1/3 plus the square root of x. But again, that square root of x we can't work with until we rewrite it. So the first step is just to rewrite that last part of the function, which gives us f of x equals 3x cubed minus x to the 1/3 plus x to the 1/2. So this rewrite is going to be what allows us to take the derivative here. So again, now that we have that, we can go term by term. So the derivative of 3x cubed, the 3 comes down to multiply the 3. We get 9x squared minus 1/3 x to the negative 2/3, because again 1/3 minus 1 is negative 2/3, plus 1/2 x to the negative 1/2. So the 1/2 comes down, and half minus 1 gives me negative 1/2. For now, you don't really need to worry too much about simplifying. You only need to simplify if you're asked to simplify, or if you need to use your derivative to find something further. So for now, just keep practicing the rules and don't worry so much about algebraic simplification of your answer. Part C. We have 10x to the 4th minus the 4th root of x plus 2 over x cubed. So again, this function demands a rewrite before we can actually use our power rule. So the first term stays the same, 10x to the 4th. But the second term, the 4th root of x, is going to be rewritten as x to the 1/4. Our third term, 2 over x cubed, we're going to bring that x cubed term up by making the power negative. So now that we've rewritten everything, we have things in the right form, which is x to some number. So now we again can go term by term and take the derivative. So the first term, the 4 comes down to multiply the 10, giving me 40x cubed, minus the 1/4 comes down. 1/4 minus 1 is negative 3/4. Now here, the negative 3 is going to come down to multiply the 2. So I'm going to write this as minus 6x to the negative 4. And again, it's minus because this negative 3 multiplied the 2, which would give me plus negative 6. So instead, I'm going to write it as minus 6x to the negative 4. Part D. Again, we're going to start with a rewrite because the last term has the square root of x in it. So I'm going to rewrite the last term as 2x to the 1/2 power. But now that I've rewritten it, I can go ahead and take the derivative term by term. So the first term, we had minus 3x to the negative 3/4. So here, the negative 3/4 is going to multiply the negative 3. So the negatives are going to cancel, leaving me with 9/4 x. Now negative 3/4 minus 1 is negative 7/4. The second term here, the 1/2 is going to come down and multiply the 2. Since half times 2 is 1, I can write this as 1 times x to the negative half. You don't have to write that 1 in front of the x if you don't want to. Anything times 1 is just itself. But if it helps you remember the process of what you did in use of the formula, you're free to use it if you'd like. So now we've computed a bunch of derivatives that have multiple terms that are added and subtracted. The next rule that we're going to talk about has to do with second derivatives.